Hey everyone, and welcome back to the channel. Today we're tackling LeetCode problem number 2, add two numbers. This is a medium difficulty problem, and it's a classic that often shows up in coding interviews. The problem statement is pretty straightforward. You're given two linked lists where each node represents a digit and a number. The lists are presented in reversed order, meaning the ones digit is at the head of the list. Our goal is to add these two numbers together and return the result as a new linked list, also in reversed order. For example, if one list represents 342 and the other represents 465, the result should be 807. Seems simple enough, right? But there are some interesting challenges we'll need to handle, such as carrying over digits and dealing with lists of varying lengths. Let's dive into some examples to make it even clearer. Understanding with examples. Let's walk through a couple of examples. Imagine the first linked list is 2, 4, 3, representing the number 342. The second list is 5, 6, 4, which is 465. When we add these, we start from the least significant digit, which is the head. 2 plus 5 is 7. We put 7 in our result list. Then 4 plus 6 is 10. We write down 0 and carry over 1. Finally, 3 plus 4 plus 1, carry, is 8. So our resulting list is 8, 0, 7, representing 807. Now let's consider a case with unequal lengths. Suppose we have 1, 2, 3, and 4, 5. We can simply pad the shorter list with zeros conceptually to handle the addition. In this case, we get 5, 7, 3. Getting a clearer picture? Let's explore a brute force approach to see how it compares to an optimal solution. Brute force approach. One way to approach this problem is to convert each linked list into an integer, add them, and then convert the sum back into a linked list. This approach is fairly intuitive. We traverse each linked list, building up the integer representation. Then we perform the addition and reconstruct a new linked list representing the sum. However, this approach isn't very efficient, especially if we deal with extremely large numbers larger than the maximum value an integer can hold. You'll quickly run into overflow issues. So, while straightforward, this brute force method has significant limitations in terms of scalability and potential for errors with large numbers. It would also be inefficient in terms of time complexity. Let's move on to a more efficient approach that avoids those pitfalls and which also showcases dynamic programming elements. Optimal solution. The optimal solution leverages the iterative nature of linked lists. We'll iterate through both lists simultaneously, keeping track of the carryover digit. We create a new node for each digit of the sum. This requires careful consideration of the case where one list is longer than the other, and handling the final carry. The solution is remarkably elegant. We use a dummy head node to simplify the construction of the result list. At each step, we add the values of the current nodes from both lists, or 0 if a list is shorter. Then we add the carryover, get the remainder, the new digit, and set the carry for the next iteration. It's an iterative approach that efficiently handles large numbers without hitting those overflow issues from the brute force method. This dynamic approach makes the solution both efficient and easy to implement. Let's translate this into Python code. Code implementation. Let's see the code in Python. We'll start by defining a linked node class to represent nodes in our linked list. Then we define our addTwoNumbers function. We'll use a dummy head node to simplify the list construction. We iterate through the lists, adding values, handling carries, and creating new nodes, until both lists are exhausted and the carry is 0. The code is relatively concise and easy to follow. Remember, careful attention to edge cases, like handling empty lists or lists with different lengths, is crucial for a robust solution. I'll add comments to the code to make it even clearer. Show Python code implementation. Time and space complexity. Now let's analyze the time and space complexity of our solution. The time complexity is O of n, where n is the length of the longer linked list, because we iterate through each list at most once. The space complexity is also O of n in the worst case, as the resulting list could potentially be as long as the longer input list. This makes our optimal solution highly efficient, particularly compared to the brute force approach. We've achieved linear time and space complexity, which is excellent for this problem. We've successfully optimized our algorithm to perform very efficiently. In terms of practical application, this algorithm is ideal for scenarios where we need to perform arithmetic operations on very large numbers efficiently, exceeding the capacity of built-in data types. Engagement break. So, we've successfully tackled LeetCode problem 2. Before we wrap up, I'd love to hear your thoughts. Did you find this explanation helpful? What other approaches did you consider? Let me know in the comments below. And don't forget to like this video if you found it useful, and subscribe to the channel for more LeetCode solutions and coding tutorials. Hit that notification bell so you don't miss out on future uploads. Let's move on to the conclusion. To summarize, we've covered LeetCode problem 2, add two numbers, exploring a brute force approach and then implementing an optimized solution with linear time and space complexity. This problem highlights the importance of considering various algorithmic approaches and choosing the most efficient one for a given task. Understanding linked lists and dynamic programming concepts are key to solving problems like these successfully. This is a problem that commonly shows up in coding interviews, so make